Without further ado, I will directly go to the topic and try to explain to you about machine-to-machine communication, impact of machine-to-machine communication on disaster management in future mobile networks. My name is Dr. T Weerawardane. As already given the explanation, I am doing research in communication department, University of Bremen, Germany. So let's start with the outline. First, I will give a brief overview about machine-to-machine communications, how we can use mobile communication with machine-to-machine communication, and what are the challenges that we have, and how we can meet these challenges. Then I will focus on a specific section of mobile communication, the modern mobile communication, that means long-term evaluation, the uplink scheduler, and how we cope with quality of service aspects and the high data demands. And I will also show some simulation results, and also some other results you can refer the publication. And then also proposal for the machine-to-machine communication, how we incorporate into the current mobile communication. Finally, the conclusion and outlook. Let's start from the basic. Machine-to-machine communication means there is no human interaction. Machine talk with another machine and update information and produce some results. Or when machine is standalone, as we know, we need an operator. Without operator, there is no meaning of that machine. Every time to operate the machine, we need operator. But when the machines are interconnected, we can efficiently improve the productivity of the production line. Or when it is networked, there is a great deal of operability outside the machine. And anywhere in the world, you can operate this machine. So then the machine's value increase. So, of course, when the mobility comes to the play, so mobile communication or wireless communication come into the picture. So let's look at first brief overview about what kind of applications that we have. So, for example, smart metering and remote monitoring aspects. Widely we can use this machine-to-machine communication. For example, for remote areas, we have water treatment plants, or we have grid stations. For example, a smart grid, very popular, and they adaptively focus on the consumptions, and based on that, supplies are adjusted. And also we can have we can check storage tanks. The level of the tank can be measured remotely, and there are a lot of applications. If we cannot reach the place where the machines or the remote areas, we can use mobile communication. Previously, we need wire or satellite communication. For satellite communication, it's a bit expensive. When it's come to the mobile communication, we have cheaper option because data communication is much cheaper today. Let's look at the transportation, intelligent transportation systems. For the intelligent transportation systems, we can track the vehicle on the way, and also we can prepare, warehouse people can prepare for the delivery, and the things can be very efficiently handled. So productivity can be improved, very cost effective. Let's take the medical area. That also we need the doctor in front of us, but the time is changing because you can stay at home and your pulse rate and all the things are monitored and send it to the medical centers. So they can give you recommendations. And also, of course, doctor cannot be replaced by a machine, but the information can be transferred over the machines. And inside the body, we have some networks, and all the functionality can be monitored and can be reported, and timely action can be taken. So let's look at the safety and security area. In defense area, because there are a lot of machineries that we can protect misuse, or we can track them, or any safety features we can address with machine-to-machine communication. So this is a large area. If you see normal householding, house appliances, it is in near future we will get all the house appliances with IP address probably, because it's automatically can update the firmware, and it can be checked the conditions of the machines and all the lightings and all the energy sector. So all of these areas, machine-to-machine communication is booming from 2009 to today very fastly. One of my research students is doing this area of research, so I'm today focusing on particular aspect of scheduler. So before we get into that, let's look at how the world using these machine-to-machine connections. In 2009, 87 million, you don't think this, 87 million people connections transmitted over the wireless media, and it's mobile connections. And we expect 500 million in 2014, even more, because we are exponentially growing our requirements and also the development. And current wireless here means 3G wireless systems. We know spectrum is not that flexible, so we have limited capacity. The cell breathing range is small, so these problems we had. So we cannot cater full data demand. So we have to go for high data demand and challenging technology. The promising technologies are the LTE and LTE Advanced, 4G technology. Here LTE Advanced is the 4G technology, LTE a little bit in between, because IMT 2000 recommendation compliance with LTE Advanced. Let's look at the system, how we can integrate these networks into the LTE system. This LTE-M means machine-to-machine communication part included. So we have a lot of capillary networks. We have a lot of capillary networks which have a lot of sensors. And those sensors provide you information, and the gateway can transfer those information. Also, you can directly connect to the broadband network, and you can transfer the information. And the main issue is identity of small devices, because sensors can have even dust particles. That is a sensor which can measure the temperature or any other pressure or environmental condition, anything. So main issue with the current mobile communication means 4G mobile communication, radio resource allocation, very complex task. As we know 3G we have a complex calculation in time domain equalization effort. And when it's come to the 4G technology, this effort completely removed, because we have FFT technology and very easy to calculate the frequency domain equalizations. So with that, but we have a complexity in other part, how we allocate the channel to the users depending on total number of users. So this part we have to address. So let's look at basically how these all together comes together. I talk about applications. So what is the main concern? There are a large number of applications worldwide, and then the message size are varying. Therefore, different message size are varying, as well as different quality of service requirement. As we all know today, quality of service only is not the concern. Quality of experience is also the concern. How the user perceive the things. So when we come to the upper part, we have machine-to-machine applications, large number of devices, different size of messages, different size of requirements. When you come to the lower part, we have regular services, regular mobile services, voice over IP, video conferencing, or any other FTP, HTTP downloads. So together, resource allocation is a great issue. So when it's come to the scheduler, LTE scheduler is the main part which allocate the radio resources. So we already discussed with the previous paper about downlink, but today I'm going to address about uplink, because we also have great amount of data through uplink. So let's look at both constraints. One constraint is quality of service constraints. Second is we have to also consider the channel condition of each user. He may be traveling or staying someplace, so channel conditions, and also fairness. If you have same type of QoS users, we have to also give the proper fairness. And also buffer size mean internal things. We also should consider how much data he has. So mainly the uplink, when you consider uplink, there are particular concern. We need the small band in contiguous manner, because uplink we use single carrier transmission. So we need all the PRBs, physical resource block, the small bands together. This is one constraint. And the other one is power control constraint, because user has a power limited. So, but when user has to increase the power in order to transmit. So, of course, mobile has limited power. So let's consider main part of the scheduler. We have